welcome. I'm going to talk to you about a topic that you haven't heard anything about, AI. I'm sure it's very unusual to you. But no, seriously, I'm Kirk Barker. I'm a product manager for Meta, and we are going to talk to you about AI today. Now, how many of you guys remember the first time you created a VR game? Okay, so I don't know about you, but for me, it was a little bit daunting. You know, all the stuff and skills you had to learn to do that, right? It's not just about doing coding. I mean, I have a strong technical background in coding. That was easy. But to develop a game, you have to worry about so much more. You have to worry about creating the assets, creating the scenes, creating a plot flow, making things work. And that's before you even get to the harder problems of promotion and monetization and everything else. There's 1,000 different details that you have to worry about as you create a game. Now, our purpose in introducing artificial intelligence into the developer workflow process is to remove as much of that as we can. Our vision would be you would be able to concentrate on character development and plot development and your storyline, and all the rest of the mundane stuff would be taken care of for you. Now, I hate to tell you we're not quite there yet, but the long-term vision is we would be able to get there, and we would be able to simplify this process dramatically. So that's what we're going to talk to you about today. We're going to talk to you about introducing AI into these developer workflows in a way that it simplifies the job for you and just makes things a lot easier. So let's start out with Passthrough Camera. Now, Passthrough Camera we released to the public in the beginning of May, so it's been less than 5 months, and the reception has been great. Since we released it, we've already seen dozens of launched apps, and we have hundreds of developers working using the Passthrough Camera API to create just amazing stuff. We have apps running ranging from gameplay, like Resolution Games 20 guys, which use it to just improve their gameplay, to productivity and personal improvement apps, like Pencil, which teaches you to draw. Or we have other apps like Stencil. Stencil you project in your home and it allows you to redecorate your home. Or even Piano Vision, which teaches you to play the piano. These are just amazing apps, and they can all do this because we provided access to those forward-facing cameras, and it fed those into machine learning and OpenCV algorithms. Some of them are using object detection to track objects for general gameplay. One app has even gone so far as they're using the object detection to analyze the serving racks on the back of routers and say, okay, was this wiring correct? Are the right ports plugged in? The potential of what you can do when combining machine vision and even LLMs is just amazing. So in this example I'm going to show you, we've hooked up the pass-through camera images coming in, and we're feeding them to an LLM. Now, don't be alarmed if about halfway through here you think you're not hearing things correctly, because we're actually going to ask the question in 2 different languages and still see the response come back. So one of the really cool things about LLMs is they're kind of natively optimized for the different languages you want to work with. You don't have to do in-language customization in most cases. So let's just watch this one in action.
Hey, what type of plant do you see here?
The plants shown are varieties of Dieffenbachia and possibly a calathea. Dieffenbachia, recognized by its broad, variegated leaves, is a popular indoor plant due to its tolerance of shade. The plant with narrower green leaves looks like a calathea species, appreciated for its striking leaf patterns and colors.
Was für eine Pflanze siehst du hier?
Das Bild zeigt mehrere Zimmerpflanzen, unter anderem eine Sorte der Gattung Dieffenbachia, erkennbar an den großflächigen, gemusterten Blättern, sowie wahrscheinlich Exemplare der Gattung Aglaonema, die ähnlich vielfältige Blattmarkierungen aufweisen.
これは何ですか?
これは観葉植物、特にアグラオネマとドラセーナの種が写っています。アグラオネマはその鮮やかな葉模様で知られ、観賞用として人気があります。
Now, if you're not a little bit amazed by that, something's wrong with you. This is just amazing stuff. And plus, you just learned something coming to this meeting. So you kind of check the goal. Deepen Bachia, or something like that is the flat name. Okay, now I mentioned that we get the camera images and then we can pass it to machine learning or OpenCV algorithms. And in doing that, the imagination is just almost unlimited. We're going to go through 4 or 5 different apps today and show you some things from each of them where people have just imagined something particularly cool that we wanted to show you. Some of these device models or some of the ML models are running on device, so they're running on your Quest 3 or Quest 3S. Others are cloud-based. We'll talk about some building blocks later that allow this to be very easy to build, but it all depends upon what kind of algorithm you have and where you want it to be. In this particular proof of concept, this is a remote assistant use case. For those of you who aren't familiar with remote assistants, this is where you have somebody back in a central position somewhere, and they're talking to someone in a point of view camera, like with the glasses or the headset or that type of thing. So there's someone remote and they're trying to talk and trying to help. The unique thing about this one is that we've decided to place an avatar, a virtual avatar, physically or virtually there beside you as you work on this car. So in this split image here, on this, the image on your left, my right, over here is the remote assist image. So he sees the car projected here and he can physically go around it. He's in a headset and he can see what's going on. But his embodiment as an avatar is going to show up in this right side. So he's going to move around and by doing that, he can then point at things, move around, and it really gives you the feeling that there's a person there with you, working with you to help you do this. It's an amazing use case. So I'm going to just, once again, as I play this, you're going to see this is going to show you the view from the guy that's remote assisting, and he's going to kind of come around to the left side of this hood and help the other guy. So you can see his avatar pop up over here in this screen. It's going to go up full screen, and you'll see he's in kind of the position that the original helper was in as we were doing that. So let me step back and let you see this. So here you go. He's going to come over and position himself.
Jumper cable device, but I don't know how to jump my car. Can you show me how to do it?
Yeah, sure, no problem. So you're first going to take this red jumper cable right here.
Okay.
And attach it to this red part right here.
All right. All right, and then what do I do with the other side?
Cool, and then you take that other cable and attach it to this part right here.
Okay. Great. All right, am I good to go?
Yeah, you're good to go, that's it.
Yes, that's amazing. Okay, yeah, I agree. Clap for that. Now, your neighbor who's walking by and sees you out in your yard talking to somebody to the side, might think you're a little weird after that, but I mean, it's a great use case. I love this one. Let's look at a few more. Okay, so in this particular game, this is a game called Bali. This is, I think, just got posted, just released. And what he's doing is he's using object detection of this. You see this pink ball down here? You're going to see it constantly in each of these clips. What he's done is he's taken that object detection that's tracking that and used that to introduce into gameplay. Right? And you can think of and he shows a bunch of different clips here. In this case, he's knocking down these virtual objects. All these things you're seeing here are virtual, right? But the physical ball is in a physical room and it's bouncing like it should. In each of these cases, it's the mixing of that physical reality that you've got there with the virtual objects that he's interacting with that make it so cool. Really, really, really neat stuff. Okay. So each of these, I mean, sorry if I'm a little excited about each of these. They're just amazing. If some of these don't blow your mind, I don't know what to do for you. It's just really, really, really neat. So one of the areas that we're most excited about is personal improvement. I mentioned earlier the drawing apps, there's painting apps, there's musical apps, there's all this stuff. This is such a neat area. Not only is it really varied because it's almost infinite in terms of the applicability, but it's an area where using these cameras and machine learning, you can really add value to someone's life. This particular app, this is an app called Hablar, and this is a trailer for it. And what they're doing is they're recognizing objects that are placed around the room and then using that to teach a foreign language. I know the app that I can't mention the trade name of just popped into all your minds, but think of that, but in a virtual world. Let's watch the trailer.
there. Are you ready to practice some Spanish? Can you describe the couch using these words?
El sofá es cómodo.
Nice work. Let's try a few more words around the room.
La ventana.
Your language skills are growing. Thank you for practicing Spanish with me. Do you want to start over or try another language? Super, pratiquons le français.
Again, just absolutely
Sacre bleu.
amazing. There you go. You already know Spanish. Awesome. But think about that and the value that brings. And don't think that that one's just limited to in your home, right? You could take that out to a cafe or whatever. Addition to it, it's not limited by anything physical because you can introduce any virtual object you wanted to into it. So even if you're there in your home and you only have a couch and a bed, all kinds of virtual objects could come in and teach you about them as well. Just really, really amazing stuff. Okay, now, we realize that the pace of LLMs is just going so fast. It seems like every 2 weeks there's a new LLM released and a new object tracking model, and it's so hard to keep up with. And we understand that may make the process very daunting for you. You look at this and just don't know which thing I should choose or how I could go. So what we're trying to do is make this as easy as possible for you to get this implemented. We're doing this by introducing a number of building blocks. For those of you who are familiar with Unity, a building block is basically a script that runs, and with one click you can create components into your object. So the first building block we've done is one click, it's going to add everything you need for Passthrough Camera. So that's going to get all the basic images and allow you to feed them into your app. We've added another at the kind of the basic level there with a visualizer, because this way you can pick up both eye views. And if you want to do something like binocular vision or calculating your own depth map or doing that kind of stuff, you could do it with this one. More importantly are the next two. The next one is the object detection building block. Now with it, you're going to use the default Unity internal inference engine to do the object detection, but you can substitute any object detection algorithm you want into it. So there's just a few fields that you have to change, and you can have your own object detection algorithm. More exciting, and again, I think it just goes in complexity as it goes to the right, but the most exciting is, of course, you can do a multimodal LLM. With it, there's a standard building block. The default is the Llama model, but we have prefabs for a dozen different models, and we're working to expand the number of models that we support. We have a demo that we're showing over in MPK 15 that you can stop by, and I can do some demos of this for you, but you can literally build an app in 5 minutes with 4 clicks and a few drags, and create something that actually works and you can interact with an LLM with. So really, really exciting. Now, I've just been talking a lot about Passthrough Camera and these runtime parts of LLMs and object detection that we would like to introduce and have introduced and are making available for you. But it doesn't stop there. AI can be introduced into basically every step of the development process, from the early concept art that you're doing all the way through when you're debugging things for performance analysis or looking at logs or whatever. So we would like to take AI into each of those steps. For that reason, I would like to introduce Vadi, who is going to kind of take the next step and talk about introducing AI into the developer workflows. Vadi?
Thank you for that inspiring presentation, Kirk. Just to set the expectations right, I don't have cool videos like Kirk, but I'm sure you will find this useful. And before that, I'd like to quickly introduce myself before getting started. I'm Vaidi. I work as a software engineer with the Developer and Pro Platforms group. Building upon what Kirk earlier shared, I actually wanted to talk about how we are optimizing the developer experience for the Agentic AI era. Many developers are already using AI to accelerate their productivity when building for Horizon. We want you to be able to do the same when you're actually building for the Horizon store. So whether you're an existing developer who's actually launched in many apps into the store or just looking to get started, our new AI tools are designed to help you get started quickly and kind of build with AI. We have made a lot of new thoughtful AI enhancements, and we are super excited to be sharing these with you today. First off, I'd like to start with our developer documentation. As you know, AI is rapidly evolving and changing the way we interact with digital information online. But quietly, documentation is actually changing into the second brain of AI, providing these AI agents with context necessary for them to kind of ingest them into the context window for it to be able to give useful answers. But if you think about it, our developer documentation was actually built with the goal to help human users and not these AI agents. So this is the reason why you find the documentation to be structured into different formats and pages to kind of make it visually appealing for the human users. But this in turn directly impacts the AI agent's performance, when it wants to access and navigate and actually figure out relevant documentation context that it needs to include for specific development tasks. We wanted to keep up with the space of AI agents and wanted to make our documentation AI agent friendly. Today, we are excited to announce a series of updates that we have designed to make our documentation more agent friendly. First up, we are releasing a new feature where you can easily grab the markdown version of any build path documentation page just by adding a .md to the URL. This way, your favorite AI agents or assistants can actually access clean markdown version of any build path documentation page without any noise. Next up, we are also releasing llms.txt for all our build plots. Think of it as a sitemap for the AI, where you are providing the AI agent the complete documentation index for each build paths with title, link, and summary of what the documentation contains. This way, the AI agent is actually able to figure out relevant documentation that it needs to include into its context window for it to be able to provide high quality answers. Next up, we are also releasing LLM's full.txt for all our build paths. This means you can actually plug in these files. Basically, this is essentially an entire documentation per build path in a single markdown file. You can instantly plug it into your AI assistant or agent, or if you are a fan of vector databases, you can use it for your enhanced retrieval augmented generation workflows. And finally, putting this all together, as also announced in the developer keynote today, we'll be releasing an MCP server soon, which you can directly plug it into your AI agent to get all these enhancements as tools within the MCP server. This way, all you just have to do is just install this MCP server into your AI agent and help it to get relevant documents for your queries in real time. I have an example to show you putting this all together so you can understand what's happening behind the scenes. So this is one of the state-of-the-art coding agents, and what I'm doing here is I'm just asking a specific question to it. And as you can see, it's able to infer that this is a question related to spatial SDK, and it's able to pull in the relevant documentation index for spatial SDK, and it's scanning through those, reasoning through them, and figuring out the right documentation it needs to pull it into its context window. This way, you're able to get really high quality and accurate and specifically grounded response with Horizon documentation context. And not just that, right? Not just documentation. I think one of the areas where we are seeing huge acceleration in terms of productivity with respect to AI for development is code generation. AI is fantastic at generating boilerplate code and also helping you rapidly prototype. If you have played around with it, you would know it by now. And not just that, right? If you provide AI agents with sufficient and necessary tools for it to be able to understand the world and develop an environment around you. It's even able to do a better job. In fact, it's able to even generate like VR-specific code for Horizon use cases. I actually wanted to show you a few examples here to make you understand like what I'm talking about here in terms of rapid prototyping. Here is an example where I'm trying to build a simple game for MetaQuest using just 2 prompts and the AI agent connected to our MCP tools, which I'll talk about later. So as you can see here, I'm providing my requirement as a simple prompt, and specifically what I'm asking it to do is, as I open my fingers, I want the app to spawn a virtual ball on top of the palm of my hand. It was able to help me set up the boilerplate code for the project. It was able to talk to our tools, read through our AI-ready documentation to figure out how to leverage MetaXR SDKs, and was able to produce the code required for it. And not just that, it was able to provide gesture and position information within a matter of minutes. And adding on top of that, this is the second prompt that I was talking about. I'm just asking it to kind of like to rapidly prototype. I'm asking it to add a cool shader to it so it looks interesting in my hand. And it was able to do it like pretty quickly. This demonstrates the power of like rapid prototyping that you can get with AI, specifically for Horizon use cases when you plug in our tools into those AI agents. And finally, not just for rapid prototyping, you can start leveraging them in your regular development process for feature generation, for feature addition or bug fixes. Here is an example where I'm actually asking the AI agent to make a few objects in the scene grabbable. So there are a few objects in the scene like which I'm unable to grab, and I'm actually making it grabbable, which you'll see in the next set of slides. Let's look at the video. You can see there are like 2 objects in this scene, which is basically a basket and a ball. I'm unable to grab it. And what I'm going to do now is ask the AI agent, which is connected to our tools via MCP, which is Model Context Protocol, and help it to fix and then add these objects, make these objects grabbable. Here, for instance, as you can see here, I'm just providing natural language instructions based on the scene saying that just make the basket grabbable, make the ball grabbable. The beauty of it is that it's able to talk to our MCP tools to understand the scene, to understand the entities involved in the scene, and is able to quickly figure out when I'm referring to the ball, I'm actually referring to that specific entity in my scene, and is able to actually make those objects grabbable. Here's the final output after we actually generated the code and then made those objects grabbable. I just wanted to reiterate like one important point here, which is as you provide these AI agents with tools that can interact with the world and also understand your environment better and context better, you are able to generate like better and accurate and high quality results with your any AI agent of your choice. And to wrap it up, as also announced in the developer keynote today, we are working with Unity on an MCP solution that we'll be releasing soon. Now, I'd like to hand it over to Laurent, who is going to talk about how you can leverage AI in other essential areas of development, including performance optimization and debugging. Over to you, Laurent.
Thank you very much, Vaidi. Good afternoon, everyone. My name is Laurent, and I'm a software engineer at Meta. Looking at all those amazing new capabilities and workflows, I think you're getting a good idea of our motivation behind all that AI effort, which is to give you more space to do the thing that you love, creating and building great content. And that means that essential tasks that are somewhat repetitive, we would want to leverage AI to simplify them. And one good usual suspect is performance optimization. And you don't like it. According to a recent user study we conducted, it is a tedious work, to quote here. One of the more manual and frustrating tasks in development. And we agree. Tools are hard to use. Data can be overwhelming to process. So with our new workflows, you will leverage AI for performance analysis, making it faster, but also simpler, and provide actionable insights. Let's see it in action in one of our open source showcases, North Star. This scene here that we modified for this exercise is running at about 30 frames per second, which is far from our ideal target. So when I click that button, we will trigger a perfecto trace and then ask AI to load it, analyze it. We trigger a trace, AI loads it, goes through multiple queries, and eventually provides a CPU breakdown. That is the cost of functions on the main thread. We can already get 2 outliers over there, which are mentioning light probe, a light probe anomaly. We probably want to tackle that later on. Once it's done the CPU breakdown, it continues with a GPU breakdown and concludes with some next steps. I'm kind of spoiling the future slide, but at that point, we could automate the next steps and just ask AI to, well, do it. But for something as important as performance optimization, we may want to have some more control. So let's proceed with a conversation with AI to get some pointers and maybe code snippets that we can copy and paste into our code. This is what we're doing here to improve that logic of the light probe within our project. After that, once we've done that, we can trigger a second trace and get a good idea of the improvement so far. We don't have to stop here. Now that we have 2 traced, we gave some good leads as some possible other improvements that we could apply to our project. Or we could simply ask best practices and which settings to set up to improve our performance overall. This is just one of the many AI workflows that we are approaching today. But AI is moving fast. Literally every day, new capabilities, new tools. And we would like Horizon OS developers to embrace and explore that new and exciting landscape, especially when using our tools and our SDKs. Creating with AI in Unity for Horizon OS is now a possibility, thanks to Model Context Protocols, or MCPs, as they've been introduced earlier by Vaidi. With just one prompt, here's one. Create a whack-a-mole game in VR for MetaQuest. With just one prompt using your coding assistant connected to an MCP and additional Quest functionality that we added to them, you can create end-to-end. You can start creating for Horizon OS. And I love this prompt because it's such a short sentence, and yet the concepts that are inside that are quite complex. What is a whack-a-mole game? What does that mean having it in VR? What's the impact on the interactions, on the gameplay? Well, for our coding assistant, it's nothing. It will figure it out step by step. Move, add things to your project, and you will be able to see. I love that part where you see Unity just adding things on the fly. And it may stop at some point, asking for your input, asking for your opinion, your direction. When you know what you really want, you can provide more specific prompts. And then you may enrich your gameplay, place specific object in your scene, maybe add a user interface. This is all what we're doing here. Thanks to the AI-ready documentation that Vaidi mentioned earlier, but also our suite of tools connected to MCP, the AI not only has the full context of your project, but also knows the best practices and the source code of MetaUnity SDK, which allowed us, and hopefully will allow you, to quickly create a fully functional prototype with just prompts, no prior knowledge required, and deploy it on Quest. Notice how it's using VR features, such as here interaction, but also teleportation. Now let's take a step back and look at all those capabilities and workflow that we've presented so far. What if we take them? They were in the editor. They were on your coding assistant. We take them and we bring them in headset at runtime. Well, to be able to do that, first we need an interface. Last year, we introduced Immersive debugger, a tool that lets you inspect and tweak your gameplay object in your headset at runtime. You can see it hit in action here in Beat Saber. And it gives you access to the entire hierarchy of your scene, and you can modify property or call functions directly. Now, let's supercharge it with AI. What does that mean? That means we connect it through an MCP to your AI agent. And from just inspecting and tweaking, now we can troubleshoot. We can understand, maybe instantiate new objects, new components, modify more than just properties. And if it's connected to other MCPs, we open the door to multiple new workflows. So I would like to take the time to showcase some of those possible workflows that you will see can probably apply to many different roles within your teams. Let's say I'm a developer and I'm in my application, and you can see here the Immersive debugger seamlessly integrated into your scene. And I'm testing my gameplay. Here I will be throwing dice, so one dice, and then the second one. And on the third one, I notice something's off. It doesn't feel right. So out of frustration, I'm going to ask AI, my dice is broken. What's happening? Can you fix it? Let's take just a few seconds to put that in perspective and how I would have approached that 1 year ago. My build is broken. I would have to go back to the editor and look at my script and try to understand, reproduce it in editor, fix it, make a new build, and see if it works. Or maybe I would have used Immersive debugger. Then I would have search for the object, look at the components, and see if I can see a component missing, some properties to change. But this is very manual. Now I can just ask AI. And I find that moment magical, because what will happen here? The AI has full context of your project, your code, and the scene at runtime. So it will be able to understand, okay, the dice are broken. Which dice? What does that mean? Are there dice in the scene? Which one is broken? Should I compare them with others? Then, okay, one is indeed broken. What is the problem? Is a component missing? Is a property missing? Okay, I figured that out. Here is a fix. I can do it now. I can modify things at runtime and fix the problem. Let's have a look. Multiple MCP tools call, going through the scene, finding the problem, trying things out, and eventually saying, okay, I fixed it. Fine, cool, try it out. And I throw it. Something interesting happened here. I don't know if you noticed. So I'm going to replay it. It's very cute. I thought initially it was a bug, but it's not a bug. You'll see that when I try to grab the dice, it rolls away. You can see it now. It rolls away. I thought that was a bug, and I would need to hide it for that presentation. But it's not. It's not a bug. It's a feature. The last sentence of the AI says, oh, I fixed it, and let me verify what I did by giving an impulse on the dice and seeing how it rolls away. So I found that this was a very cute moment. Now, second use case, you're a UX designer and you want to tackle localization. Okay, well, just ask AI to translate. It can translate. And you can test multiple configurations of your UI, different text size, different text length, different language, and see how it goes. The panels are now translated in Spanish. If I see a big bug, but I don't want to tackle it right now, that's fine. Let's compile a bug report and send it to the relevant person. It knows all the context, and it's very good at structuring thoughts and structuring data. Now, if somebody else asks me to change something, change the color, make it more blue, same, it can do it. Here we go. Now, some of you may want to stop me there and say, but Laurent, this is only applying at runtime. So if I turn off the application and then start it again, I've lost everything. That is a very fair observation. That is correct. That's fine. Ask AI to apply everything to the project. So as you can see, I'm very excited about those multiple workflows. And I truly believe that you and anyone in your team will find great use of this tool. With Immersive Debugger plus AI, prototyping with AI, optimizing performance, leveraging AI, generating code with AI, and all the things we've shown today, I truly believe that we are creating more space for your creative process. And this is just the beginning. Well, it's actually the end of the presentation, but that's the beginning of the journey as we'll continue to invest in improving the developer experience with AI. Thank you very much for being with us today for that journey. Yes, we have a microphone for the questions now, so please, you can align on the middle of the thing. And I welcome Kirk and Vaidi for that. Thank you very much.
Sorry, could you queue up for the questions for the mic?
I wasn't clear, sorry.
Hey there. So just kind of a quick question. This is exciting, by the way. But I noticed that when I do prototypes, I typically my scope starts here, and then as I work, it gets narrower and narrower as I find out what real and what isn't, right? So for example, let's say I wanted to do like a AI, like a ball pit for my hands to go through, and that's going to just create just a collision storm of physics, right? Does the AI have any concept of like best practices and pushback in terms of like, well, you've got a lot of collisions here. Maybe we should look at like an activation, deactivation sleep scheme or something, or like any kind of like because I only have like this much skill in some areas and maybe no skill like in tech art. And I may try to do something that tech artists should just say, like I need that pushback professionally. Do these systems have that baked in anyway?
Do you want to tackle it or?
Yeah, I can give like a brief idea. Like I think one of the things that I've noticed with these AI agents is like if you go through it with like an initial plan and then like iterate and brainstorm with it initially on like what you're trying to do before like asking it to do like the main thing. One of the things that I've identified is that it is able to kind of come up with those initial best practices, because if you think about it, these are large language models that are being leveraged in AI agents, and this is basically like probability prediction, right? Like next word prediction.
This is a pre-production problem, not a production solve. I get that.
Yeah,
yes.
yeah. And as you are able to interact and then brainstorm and then like come up with a plan, it will be able to kind of generate like better practices as opposed to just asking it to do X, Y, Z. Yeah. So that's something that I've observed. But like,
and
Laurent,
if I may quickly add to that, I found out of experience that starting with a discussion, planning the architecture, finding the possible problems, and then aligning with your coding assistant and maybe writing it down will settle the ground for then iteration, and then you can let it go. But you probably don't want to just start it and then find a problem. Well, it will be able to fix it, but maybe you're going to miss it. Whereas if you ask an audit or trigger discussion first, it will probably figure out that it is.
And I
not best
also
practice.
want to add like a couple more things. In general, like with large language models, there is world knowledge, which is basically learned through the model itself, and then there is context that is needed for custom use cases, right? Which is where tools like MCP, whatever we are building, like to talk to our documentation, comes into play. Where when both of them works together, we have seen like magic. We have seen the magic happen.
I appreciate y'all answered my question. I think I probably gave the wrong metaphor for maybe what my true question is. So if you don't mind, let me just restate it one more time. So I had a specific project where I had an existing Steam VR DirectX, and I was converting it into a Vulkan Quest thing. And so obviously we had a lot of economizing at the tech arts scale. And constantly my tech artists were coming back to me saying we have to economize other aspects of the product in order to handle the workload on the rendering side. So those types of like balances, I guess, like when I'm actually past the production, or I've done the pre-production, I think I got a good thing, I'm in production, I'm trying to like get the last little FPS out of it and stuff, and sometimes I got to rob Peter to pay Paul in these situations. I'm just wondering,
Best practice.
does it go like that way at all? Yeah.
Yeah, I think it would be great to continue async on that one. I mean, I think synchronously, but after the presentation, because it's a good point, and we've got some leads, I think.
Thank you so much.
Really great presentation. It's fun to see how far it's come since GDC and especially about a year ago. My question is that, so I really love the Unity example where you create a code snippet, and it looked to me in the animation that basically it created a code snippet and then a new .cs file each time. What sort of best practices, like architecturally, do you recommend working with AI for larger projects? Like my core script on my game is about 3,000 lines of code. I probably don't want AI just jumping in there and moving stuff around. What sort of best practices? Should I keep it as these little tiny one scripts on the side, or what?
I can take that. I think one of the things that I found useful is with these agents is, for a specific example, if you have like a description or like documentation of your own project on like how it's organized and how it's kind of like how have you made it happen, it's more like an architecture document, right? Like if the AI has that context, it'll be able to kind of like do a better job at like using only specific files. You can actually add in guardrails, you can add in best practices, and that way you're able to guide the AI to actually take a direction that you want it to take, and like put in guardrails in places where you don't want it to go in a certain direction.
Okay. And then does it have a concept of like the inspector in Unity? Because a lot of what I've done is I've set groundwork so that an artist could come in and just tweak things fairly easily.
So with MCP, yes, it gets access to that.
Thank you.
Hi, my question is pretty specific, so let me just try to set the scene. I did the MCP demo downstairs, so there's that. And then I noticed that some of the calls in the console and the headset were editor calls.
Yes.
So the question I'm asking is, I get that the runtime, the profiler is on headset, right? But it seems like some of the analysis is being done on the editor. So the question is, how is it handling dynamic content, right? You're loading scenes additively. Sometimes our lighting's in different scenes. We're loading game objects. How does it resolve those two things?
So this is something that we are exploring right now, which I believe like is quite audacious, where we want to deal with both at the same time. And we want the coding assistant to be aware of the separation and understand like things that are static, things that will be built, things that are persistent, that are on the editor, and the runtime context that is dynamic, and maybe the object doesn't exist in the editor but exists in. So we are working, and it's mainly through adding some more context and more documentation and more explanation through the MCP tools for the AI to really understand and grasp those two contexts. But yeah, as you can see, sometimes I will try something in the editor.
If I have like a dummy scene open, right, and I do my build, but the thing in the headset is 6 different scenes. One of them has lighting, one of them has my terrains.
Yes, yes.
It's going to go back and say, I didn't see anything, or how does it resolve that?
By proper error management, that's kind of like, that's on us. It's like when the AI will call an MCP tool, it is super important for the error and the logs to be explicit, to be verbose. You want to be verbose with AI. So you want to say, oh yeah, I couldn't find your object because I was looking at that scene on runtime, and then the coding agent will realize, oh, wait, no, that doesn't make sense. That's not what I wanted to do.
Thank you.
I'm afraid we are at time. We'll stick around outside here if you have more questions and answer any questions. But thank you for your time today and your attention, and we'd be happy to answer your questions.